Hello and welcome back. In this video we'll look at how to calculate the areas in normal distributions without having to resort to the fact that they are symmetric and things like this. So let's look at this first one again. So we'll assume that Z has a standard normal distribution, which means it has a mean of 0 and standard deviation of 1. And we'll find the probability that Z is less than 0. That means I need to find the area. So the entire goal here is to know what the area of this section is. So let me go to a sample problem in StatLab. So here in the study plan area, I'll go to practice, which is find the probability of a range of Z values in a standard normal distribution. So this is exactly what we're looking at. When we look at this question, it says find the area of the shaded region. The graph depicts a standard normal distribution with a mean 0 and standard deviation of 1. So again, it's saying here's the Z, the value of the probability that we want to find. The probability less than Z is 0.22. In our initial question, we wanted to look at the probability that Z is less than 1. So you can see that there's no link directly to StatCrunch, but if you go to question help, we can go to StatCrunch here and open this. And I've zoomed in a little bit so it's easier to read, but what we'll do is we will go to statistics, calculators, and there is a calculator for the normal distribution. And I think that this is a lot of fun. It just gives you the picture that you want to calculate. And so we can put in whichever mean we want, and because we're looking at the standard normal distribution, we should have a mean of 0 and a standard deviation of 1. And if we want to look at all of the values, they call it X here, we call it Z before. We want to look at all the values of X that are less than 0, and it tells us what we know, that exactly half of the area is less than, is going to be to the right, or sorry, to the left of 0. So that's 0.5. In the question that we have, in the practice question that we're looking at here, we want everything to the left of 0.22. So what we can do is we can come back to our graph and say we want all of the values of our variable that are less than 0.22, and we can compute this, and it will be a little bit more than half. Again, here's where 0.22 is, and everything to the left of that, that's a little bit more than half. So it'll be 0.58, or rounding 0.59. So this is close to 60% of the area is to the left of this marker, meaning that the probability that in a standard normal distribution that X will be less than 0.22, that probability is about 60%. Okay, so let's come back to our next question, which had been, let's assume that Z, again, standard normal distribution, find the probability that Z is greater than 1. You'll notice that I'm using a greater than 1. It doesn't really matter if we have greater than 1 or greater than or equal to 1. In this case, they'll be the same. So here, let's come back to our calculator, and what we can do is we can change the direction here. If I change the direction to greater than, it flips which side we're calculating. So now we can calculate values that are bigger than, in this instance, 0.22, and it'll calculate this area. So I wanted to calculate the area that's bigger than 1. So when we do this, we see that this area is going to be 0.158. So about 15 or 16% of the area is over here in this little triangle shape. So it means the probability that we get a value of x that's bigger than 1 is 0.158. So I can come back here and we can write that down. So the probability that z is greater than or equal to 1 is going to be 0.158. I think it was 6. So we have a probability. Now, in the last video, I got cut off right near the end, but we can assume z has a standard normal distribution, find the probability that z is between these two values. And again, our calculator is doing it with less than or equal to, so we'll just do that as well. With negative 1.3, z between negative 1.3 and 0.5, we get this picture here, where what we want is the area between negative 1.3 and 0.5. Now, when we come back to our calculator, we'll see that we're not given an option to calculate the area between two things. We can only calculate areas less than a value or greater than a value. So we'll have to be a little bit clever in order to come up with this answer. And the idea is that we do this in 2 steps. So here's the original picture, and I'm going to draw this again. So 0, 1, -1, -2, 2. So when we look at what's in red here, I'm going to draw this in 2 areas. We've got what's in blue down here, and this is going to be from negative 1.3 on. And when we look at what's in red, I'm going to draw this in a slightly different way as well. So we've got 0, 1, 2, -1, and -2. We're at 0.5. If I draw all of this in red, everything to the left of this, we'll see that in order to calculate this red area up here, it's going to be everything in here, but we're going to take away that little tail. We're going to remove it. So what we'll do is this area here, the total area, is going to be this area minus this area. We're going to find all of this area, but that includes a little bit down here that we want to take away. So we'll just subtract this bit, and what we're left with is only the area between here. So let's do some calculations. So we want to find the area to the left of 0.5. So it's going to be 69% and a little bit more. So if we come back here, this area is going to be 0.6914. Now we need to calculate this little blue area, and that was all of the x's that are to the left of negative 1.3. There's only 9.68. So 0.0968. So this area here is going to be this, if I could write, minus this guy, and I'll have to do a little bit of mental arithmetic here, but ultimately we can calculate this value. So again, we want to find the area between these two values, between 0.5 and negative 1.3. And the way that we do that is we find all of the area to the left of 0.5, and we're going to subtract away the bit we don't need. We're going to subtract away the bit to the left of negative 1.3. So in general, there are three calculations that you might be expected to make. Finding the area to the left of a value, finding the area to the right of a value, or finding the area between two values. One other thing that we might be able to calculate would be, let's say, the area to the left of some value and to the right of some other value. Again, how might we do this? Well, we could find the area of this guy and add it to the area of this guy. So the pictures help. The pictures should demonstrate exactly what's going on. The final thing that I want to discuss is that using this normal distribution calculator is very handy. However, in the past, when people didn't have quite as powerful computers to be able to do this, we would have to use tables, and this is actually something that I was taught to use when I was an undergrad, even though computers by that point were good enough. We had tables. So when we look at the table, we see that, okay, this is giving us the area to the left of this z value here. And we can come down and we can look for whatever value we want. So for instance, the way that we would read this is we end up adding the value on the left and the value on the top. So if I wanted to know the area to the left of negative 1.3, like we had been doing before, I would come down and I would find negative 1.3, and this is going to be negative 1.30 if I go a little bit farther. So negative 1.30 would be negative 1.3, and then the second decimal place is 0, so that's the first column. So negative 1.30, that value will be 0.0968, which is just what we had before. Now, if we wanted to find the value that is less than 0.22, when I click on this table, all I see over here are negative numbers. So for negative numbers, this won't work. We have to go on to the next page. And the next page will give us the positive values. So again, if we're looking for 0.22, the first digit, number past the decimal place is 0.2, and then here's 0.2. So the answer to this question, the area to the left of 0.22, is going to be right here, 0.5871. These values we can just read off of this table. It's quite handy. However, I think that the StatCrunch calculator is also just a lot nicer and a lot simpler to use than this. So either way works. You can calculate areas using the table or the calculator.